Okay, let's look at the homework 5.4, 5.5, problem number 15. Alright, so we have all these functions, two functions with two vertical lines, and first we need to pick the right region. Alright, so f of x is an exponential function, so it's going to go through 0, 1, because y-intercept is always 1. So it looks like this is promising here. Alright, this one, it doesn't go through here, so this cannot be it. And this guy, you can see that this is promising, but not this one. So it's going to be either the first one or third one. All right, let's look at the g of x. All right, g of x is negative 1 over x. So when x is positive, function is negative. So it has to be below the x-axis. So this is promising. And the other one, so this guy is above the x-axis, so the third one cannot be it. So we know that this is the region. So very first one. All right. So let's find the area of this shaded region from 1 to 3. All right. So you can tell from the picture that this guy right here is the top one, and this guy is the bottom one. All right, then it goes from 1 to 3. So this is our A, and this is our B. All right, so the area between those two curves would be A is equal to so it's going to be an integral from 1 to 3, and top curve is exponential function e to the 0.25x minus, all right, and there's a negative sign. I'm going to incorporate the negative sign to turn into positive 1 over x, all right, and the dx. All right, so we just need to evaluate this. All right, so using a fundamental theorem of calculus, so first we need to find the antiderivative of e to the 0.25x. All right, so this is e to the 0.25x divided by 0.25, right? And the antiderivative of 1 over x is natural log of absolute value of x. All right? Then lower limit goes from 1 to 3. All right? So if you're wondering how I got this antiderivative, you can do it this way. So if you have any integral of this form, say e to the some linear function, say ax plus b with respect to x, then it's always e to the ax plus b over the derivative of x plus b, which is a, plus some constant c. All right, this only works when you have a linear function here. All right, so let's go back here. All right, so dividing by 0.25, 0.25 is equivalent to 1/4. So dividing by 1/4 is equivalent to multiply by 4. So I'm going to just write it as multiply this by 4. All right. Then we can plug in. So plug in the upper limit first. So you have 4 e to the, all right, plug in 3. So 0.25 times 3 is 0.75. All right. Then plug in 3, so plus natural log of 3, because 3 is a positive number, so we don't really need a absolute value sign, and a minus, and plugging 1. So it's going to be 4 times e to the 0.25 and a minus, plus, natural log of absolute value of 1. But I'll just write it as absolute natural log of 1. Right? So we know that the natural log of 1 is 0. So this guy is 0. Right? So then I'm going to combine these two guys together, because both of these guys have 4. So this guy and this guy along with the negative sign. Right? So this is going to be equal to 4 times, right, e to the 0.75 minus, right, so 4 is factored out here, so we have e to the 0.25, then plus natural log of 3. Right? So this is the area of the shaded region. Alright, so let's type it in to make sure. Alright, so the answer we got was 4 and the parenthesis e to the 0.75 and the right arrow minus e to the 0.25 and right arrow parenthesis and a plus natural log of 3. Alright, so let's check, submit for testing. Alright, it came back and looks like we have the correct region and we have the correct area. Alright, that's it. I hope that this was clear.